Welcome, everyone, to the April Grand Rounds for the Mailman Center for Child Development. My name is Bob Pfeiffer. I have the pleasure of introducing Dr. Mark Van Dam. Dr. Van Dam got a master's and PhD in linguistics at Indiana University and did a postdoc at Boys Town in Omaha, part of my home stomping grounds. Today, his home away from home is the Department of Speech and Hearing Sciences, Elson S. Floyd College of Medicine at Washington State University. His interests cover a wide variety of areas, all dealing with language, both production and perception, and he has blended with that the area of childhood deafness for his research. Today's presentation is the spoken language of children with hearing loss in natural contexts. It is my privilege and pleasure to introduce Dr. Mark Van Dam.
Hello, thank you for having me. Glad to be here. As Dr. Pfeiffer kindly pointed out, we'll be talking about spoken language in children today, and particularly in natural context. I put just a brief note. There'll be a little bit of time at the end for questions, and I'm happy to talk about questions. This is kind of a high-level talk, high-level discussion today. So I have a bunch of empirical results, but there's a relatively high-level stuff. So all the slides are numbered. If you have a question and you want to refer back to the slide, that's for the user and for the Q&A type thing. So why don't we carry on? So I'm going to show a whole bunch of pictures of my own children, and this because I don't have to get permission to show them. So here's a picture of my son when he was a young kid, of course, and with his babysitter, our dog, the chocolate lab there, who's no longer with us. Of course, his name is Lingo, because that's the background. And there's a big question here that a lot of us are interested in, and a lot of us have thought a lot about, and that is how do you wind up with a little baby like this and then get language in them? And what's the course of development for this little boy, and how does he get language in his head? My son happens to be a typically developing kid, so I had no concerns about him, and I still don't. But he, learns language just like all of us. And language is the answer to this wonderful riddle of the human existence, and that is, what do all people have and only people have? And that is a really, really short list of things that perfectly captures all people, but and captures nothing else. There are some creatures that can communicate, but none of them use language. You've never met a person who doesn't use language. Well, if you do, they have a disorder, of course. So, we don't do some things, but we all have language. We all have natural language. So one way to study this, an important way to look at any problem, is to look at the periphery and to try to see, if you stress the system, if you stress the problem, what happens when you interrupt it at some point, and how do you examine the consequences, the time course of development, the mechanisms of development, when you look at when something isn't working right. So here are a bunch of kids with assistive hearing devices. The boy on the lower right with a cochlear implant, the boy on the lower left there with a hearing aid. And the big picture question here is, what happens when you have hearing loss that interrupts that ability to acquire natural language or natural spoken language? And then there are many, many questions about auditory perception and speech production and many different domains. So the big picture here is about cognitive development. So I'm going to talk a lot about technology. I'm going to talk a lot about things like signal processing and computers and so on, again, at a high level. But I don't really care about those things. What I really care about is cognitive development and language development. So the big picture questions are what's cognitive development look like, and how is that shaped by the linguistic environment, which you have access to through the auditory environment? What roles do speech perception and speech production play? Those are not the same things, of course. So how do we study those things, and how do we look at how their influence on speech and language development? And then, of course, in the face of hearing loss in particular. So we'll talk about a bunch of these things. Since I'm an academic, I, want to talk a little bit about the history of this. And these are kind of an interesting roadmap for where we came from and then where we're going. First human voice was recorded in 1859. That's 165 years ago. So that's a long time, and no one who was alive then is alive today, of course, but in the scope of human history, this is a very, very short time frame. Radio, mass communications, propaganda happened in the 1920s. Neumann is not, or Neumann is not, he's not an academic. He's the guy who made the microphones, the big bottle microphones that we see in historic stuff. Those were important steps in technology and important steps in how we thought about sound and how we thought about preserving sound. So before 1859, there was no way to preserve sound. Well, there was one way. Poetry is what we did, and we used writing systems, but that's not the sound. Those are symbols. So we didn't have the ability to do this until, well, only 165 years ago. 1947 was the development of the first transistor. We went from vacuum tubes and radio transmission and a lesser ability to actually take permanent recordings of things. And by the 1950s, psychologists and people who were interested in language development and language use started to take audio recordings of people's speech and permanent recordings. People started thinking about kids, not early on. By the 1970s, we started to take long form recordings. And those were, there are a total of 3 papers from Harkness and their group looking at Kenyan school kids in the 70s, and they would wear lav mics. Corman did similar kinds of things. They put a kid in an apartment and have him wear a wired lav mic for a whole day and record to a mainframe computer set up in the apartment next door. They started doing research on infants and started looking at recording these kids and then analyzing those recordings. Hart and Risley is the second to last one there, starting to do longitudinal multi-hour recordings. And they started in the late 80s, and it took them 3 years to make the recordings and then 6 years to analyze them. So they spent nearly a decade just taking long form, day-long-ish recordings from 42 families. Then starting in about the early 2000s, there has been an explosion of the internet and an explosion of a whole bunch of different technologies that have allowed us to take long form recordings so that somebody like me can get a research grant and take many, many hours of recordings, which I'll describe in quite a bit of detail in a moment. And this was quite a leap. So if you think about the time course of this stuff, our ability to take these recordings and the ability to analyze them has really changed dramatically. There's a problem though, and the problem is that speech and language is behavior. So, and I think of this as a very brief aside. This is a sort of anti-Chomskyan view, or in favor of the McWhinney-Bates type of view of this kind of thing. Behavior is messy, and language is a behavior. Child speech data is expensive to collect, difficult to analyze and interpret. And that's true today, just as it always has been. So here's another picture of my boy when he was a baby. And here he is enjoying bouncing in his little seat here. I took the photograph. So here's a little, here's a timestamp on it. It says it's 7:57 and he's having a fine time of it. And in the next picture, also timestamp 7:57, he's becoming a little bit more pensive. He's not quite sure what's happening. In the next picture, still in the course of a minute, same view here, that lower lip starts to come out and he's starting to have a bad day. And then the wheels come off. And if you've ever been around a child, this happens very quickly. This is not a particularly mercurial child or unusual environment. He's losing it. And this is a challenge for a lot of the ways that we try to collect speech and language and analyze those things from an audio perspective. So child research studies suffer from a number of problems because this is so messy, because it's expensive to collect the data. We have small sample sizes. We don't account for individual variation as well as we could. We have ecological validity issues. The stuff that we collect is not very natural. I have down the hallway from me here in my lab a big sound booth, and we bring kids in there and they go in the sound booth and they close the door, and mom's outside, and I've got microphones and cameras and all sorts of things. And it's a very unusual environment. Better to collect it out in the wild. And we poorly represent populations that are younger, populations that are also much older, non-typical populations. The messiness factor increases dramatically as we get away from the typical middle of the distribution there. And the data then are relatively sparse. So we have outdated data and we have problems with those things. For deaf and hard of hearing kids in particular, there have been a number of changes over the course of the last, I'd say roughly my lifetime. There have been some dramatic changes in hearing loss. Well, if we go back to the beginning of the sound collection in the 19th century, if you had hearing loss, you'd get a hollowed out sheep's horn and you get to hold it up to your ear, and that was your hearing aid. And technology has been pretty terrible, but starting 40-ish years ago, we started to get cochlear implants, we started to get signal processing improvements and so on. But there were three big things that have happened to change the population of kids with hearing loss. First is universal newborn hearing screening. 45 years ago, the average age of identification of hearing loss for children was 30 months. That means that the parent brought the kid to the pediatrician at 2.5 years old and said, usually to the pediatrician, there's something not quite right. And the pediatrician would then get involved, and we get pediatric audiologists involved and so on. Today, due to otoacoustic emissions and auditory brainstem response and early identification of universal newborn hearing screening, the average age of identification is more along the lines of not 30 months, but about 30 hours. Now, I know we don't actually formally identify using ABRs newborns who are 1 day old, and it really is a little follow-up of a few days or a few weeks later, but we bring the knowledge of hearing problems down to more or less the moment of birth. And that is an amazing ability then to intervene with those kids from a speech and language perspective is utterly invaluable. We also have much better intervention. The technology, cochlear implants, the first cochlear implants were about 1980. They were not very good. Today, they're very good. Hearing aids, FM systems, of course, we don't use FM anymore. We use Bluetooth and other things, but ways that we have AAC devices across the board, but also technologies that we're able to intervene much younger and with much better technology. And finally, public policy and educational policy has changed dramatically. If you were born with a severe hearing loss in centuries ago, somebody would take you by the hand and probably walk you out into the forest, never to be seen again. And that's certainly not how we treat people with disorders and disabilities today. If you have a mild to moderate hearing loss, you're reasonably well intervened. Chances are pretty high you're going to be mainstreamed in education and graduate on time and be a productive member of society. So all of these things put together, would you rather be a hearing impaired kid born today or born even 10 years ago or 30 years ago or 50 years ago? It's not even close. Today is by far the best, and tomorrow even better, we hope. So when we do these child research studies, we can address these problems, these criticisms. These are big picture criticisms, but we can have huge number of observations rather than small sample sizes. We use powerful statistics and structured models to try to get at relationships and try to look at the mechanisms of what's causing the observed data that we see in these kids and in their language production. Obtain data in situ, so solve or address, I should say, the ecological validity issue. We can specifically target younger, non-typical populations, young children with hearing loss in my case. And we use modern methods of data. We talk about the results. We have the ability to disseminate those things and really get it out into the public science discussion to improve the kinds of things that we do. So some of you, I'm sure, have heard of this Lena device, and this is a little wearable recorder. Here's a picture of one. It's about half the size of a modern cell phone and considerably lighter. It's a dumb audio recorder. Dumb in the sense that it doesn't do any onboard processing or anything like that. You just hit record and it records. That's a picture of me with my son and my daughter. My son's wearing one of those in that little red shirt that he's wearing. It's got a pocket on the front, and you face the recorder out and you turn it on, and it records from the kid's perspective all of the audio that the kid hears in a running record for the whole day. And there he is on the lower left there, wearing another shirt with a little cartoon pocket on there. And we put it on, he wakes up in the morning, and he's much older now, but we wakes up in the morning, we hit record and put it in the little pocket, and it records all day. So we get something like a 10, 12, 14-hour recording, depending on how long he's awake and exactly how long you manage those things. So we collect a 12-hour audio recording. What do we do with such a thing? Well, we want to generate data out of that. And this was not possible in the earlier days of this, including in my lifetime. We didn't have the technology to process and manage this computationally. But now we have things that are in the family of automatic speech recognition or automatic speech processing. The goal of automatic speech recognition is always the same thing. All automatic speech recognition does two things. One thing is determine the boundaries, so determine the segments in the temporal domain. And then the second thing is to put a label on those segments. And when you use something like Siri or Google Voice or something, they're trying to map lexical items onto those segments or onto those utterances, or map words so that you can read the output. We don't necessarily do that. Sometimes we want to do text, but there's a relationship between how good the performance is based on the input and based on assumptions of the input. So maybe you want to just look for syllables. Maybe you want to look for phonemes. Maybe you want to look for biphones. There are lots of things that we could choose to look at, and the performance of the system will depend on what kind of things we look at. So we take these day-long recordings, and here are some technical details that we don't really need to get deeply into, but we wind up with a waveform. You can listen to it. It's high enough quality to listen to. It's better quality than, say, a cell phone transmission. And then you see a waveform down there. Here's a little snapshot from, I don't know if that's Prod or Transcriber or one of these software tools. And then there are labels below, and you can see that they're segmented. So one of them says man, one of them says conversation, and one of them says SIL, probably for silence, that kind of a thing. So the software is looking to segment these and then diarize the output. And we're interested in identifying things like when and where live human vocals occur and when other acoustic events occur, like when the TV's on, when there's noise or silence in the environment. And once we've identified live human vocals, then we can get more deeply into, well, who's talking and when, and maybe how many syllables they're uttering, or what their prosody looks like, or bits of other analysis that we're interested in. When I said bits of other analysis that we're interested in, these are some of the factors that we look to develop. So when we look at we have hearing details, of course, of people, things like pure tone average, speech intelligibility index, when people were identified with hearing loss, what kind of hearing loss they have. We do, formal audiology and tympanometry on these kids. And we have all of those variables built into giant databases. We have outcome variables that are familiar to educators and SLPs, like the Mullen test, the Castle, the Goldman-Fristow, the MacArthur-Bates. There are a number of different tests, and there are many, many hundreds of these that we look in. There are Lena-generated variables, things like who's talking and when, whether the vocalization is a speech-like vocalization or a vegetative cry vocalization, for example. And some standardized variables like how often the child is vocalizing, how often adults are vocalizing, how many conversational turns kids engage in. We're especially interested in conversational turns because that's a measure of joint attention, and we can get at language learning issues about when children share linguistic events with the people around them, including their siblings or others. Of course, we have the usual demographic variables. We can generate linguistic or communicative variables, things like conversation, talker roles, phrase boundaries, so on. My background and training is also in acoustic phonetics, so I look at things like fundamental frequency, formants, various stability characteristics or entropy in the signal, like shimmer and jitter, for example, temporal characteristics of the signal. And then we can ask questions that are very basic, but no one has ever had the ability to ask these questions before. So we can take as input a day-long recording and do acoustic phonetic analysis of this and answer a question like, how long in milliseconds does a child's utterance tend to be? Or on average, how long is a child's utterance? How many syllables do they speak in a day? Those kind of things. And I'll show you some of those results in a moment. There's a bunch of logos from computer programs at the top there. As Dr. Pfeiffer mentioned, my background is linguistics and computational linguistics. I never thought I'd be writing quite as much computer code as I do, but we use programs. There's MATLAB and Prot and Python, R, C++, SQL. We use these programs as tools to manage the databases that we create and the analysis that we do. And that analysis is different in scale. That is, we have a lot more data. We build matrices or databases that are tens of thousands of columns by billions of rows, and then we do analysis on those things using modern statistical techniques. But it's also different in kind, because compared to the old experimental psychology or developmental psychology routines that experiments that we did, starting in the 50s and 60s and 70s, you might only have a few dozen pieces of data, and then to go confirm or query the data, you could go look at 20% of it or 30% of it or something. If I have a billion observations, say a billion utterances that I use to model this stuff, I can't go back and look at any appreciable number of it. That might be a million seconds of audio or something like that. And we can't do that. So we have to use automated and unsupervised methods. So it's different in scale, but it's also different in kind in many ways. Of course, there are reliability issues. Here's a paper that we did, and many people have looked at reliability of automated and unsupervised methods. And as I just mentioned, those are different in scale, but also different in kind. So we build ways to address how computers are making decisions about audio files that are a little different from how human brains and human ears make decisions about the environment that we're in. So to give you a little bit of a flavor of the data that we have, again, this is very high level discussion of this, but the first thing we have to do, of course, is build baseline observation, baseline data. So we have typically developing kids. My preferred bit of data there is to have kids who are about 3 years old. And I like 3-year-olds because they've had plenty of time to learn language, but they haven't been corrupted by literacy. So they have lots to look at, but they're not trying to become literate at the same time. So we have typically developing kids as a baseline and as a comparative group. And as I've mentioned a few times, hearing loss is another critical part of my own research agenda. But then we look at autism and Down syndrome, kids with language delay, used to be called SLI, special language impairment or specific language impairment. I have a colleague here in my department named Nancy Potter, who is a motor speech person, a child motor speech person, and she is an expert in a rare motor disorder called galactosemia that has speech production consequences. So by the luck of the draw, Nancy and I are pals. So I have done a bunch of work collecting recordings from kids with galactosemia, and we look at speech production characteristics and language development in kids with a rare genetic disorder. And then we can compare those to typically developing kids, kids with specific disorders and issues going on with those kids. We have recordings from newborn onward. We use mixed and cross-sectional longitudinal designs. In my lab, we have something on the order of 4,000 plus days recorded, or about 45,000 hours of audio, probably closer to 50,000 hours of audio. And it sits on giant servers in the lab, and that's the principal database that we use to address some of these things. We have to use automatic analyses, of course, and the variables I mentioned on the other slide, on the previous slide, to look at how those variables are related to one another and how they might be predictive. This is a single slide that is a slight diversion. It's a little bit of an advertisement for another project that I don't want to get into a lot of detail on, but there was a question that came up. I would meet folks like you guys, and I would go give talks at meetings and conferences and so on. And somebody would say, "Oh my goodness, you have 4,000 days of recording, and you have these tens of thousands of hours of these hearing impaired kids, for example. I've got a bunch of recordings of kids with Down syndrome, or kids who are much older, or kids who speak French or Swahili or whatever it is. We should collaborate." And that's a great idea, but it had certain challenges with it. And those challenges are, for one, how do we get the data? Who's going to do the analysis? Who's going to organize that data in a way that becomes useful? We use these high-powered computer programs in order to access this stuff, and it becomes a challenge to do that work. So we needed to have a method to share that data. We were fortunate enough to convince the National Science Foundation to fund a project that became known as Home Bank. And there's the web address of it there. And it was a collaboration between Anwar Lamont and me and Brian McWhinney at Carnegie Mellon. Some of you may know Brian and may know his work going back decades now of the TalkBank project, and specifically the child's database. And there's a bunch of software with it too. Generally speaking, TalkBank is a public repository organized into many corpora or many organizational units for people to not have to endure the cost and expense and time of original data collection. So there are databases there that are organized around right hemisphere or aphasia or different languages, different ages, and so on. And one of those banks is called Home Bank. And Home Bank has 4 parts to it. One are the day-long recordings I've been describing. Some of them are public, some of them are semi-public. The metadata, some of those other data points, a code repository stored on GitHub for people to process that data and think about those things a little bit. So, for example, I've spent some time building some tools that would deal with the audio signals in the temporal domain and generate variables. And I spent some time building that software, and then we just make it available to people so they can use those tools and they don't have to reinvent the wheel in order to be able to deal with the data. And then a scientific community that came out of this called DARCL. And DARCL is a group that meets online I forget what it is, every 3rd Friday of the month or something like that. And to talk about the issues that come up with dealing with day-long recordings and collaborations and grant proposals and students and so on. You can be a member, you can just click the website and go there, and you can lurk, you can collaborate with people, send your students, send yourself, and it's a way to access and manage and think about that resource there. And that is we hope, a permanent resource. So right now there are something like 2,500 recordings on there that constitute about 15,000 hours of audio memory serves. So that's the background, and that's kind of a long background to talk about, to get into the meat of some of the empirical work and some of the work that we've done. And if you are a researcher like me, and you see all of these variables and you hear about all this naturalistic data and all of the kinds of top-down questions about language development, I hope it feels like a fascinating playground to play in. I have a serious problem because I don't really know what to work on first, and I have thousands of questions about this stuff. So we've hacked away at a bunch of empirical problems. So I'll describe a number of those empirical problems. I have about 6 or 8 slides here that will describe a dozen or so projects that we've done over the years looking at this database and looking at this kind of work. One of the cool things about this is that a lot of people have asked these questions before, or have maybe asked them unseriously because the technology didn't exist or because the database didn't exist. I mean, most of us have probably wondered, boy, I wonder a question like, I wonder how many words a day my kid hears, or a kid hears in a day. And then if you ask that question in 1980, you'd go, well, that's an interesting question, but how would you measure such a thing? I don't know. Well, we can measure those things now. And it's not perfect, but we put a recorder on a kid and send him out into the wild and then rinse and repeat several thousand times. And we can get a pretty good estimate of how many, say, utterances per day a kid hears. And in this case, we're interested in a couple of related questions and sub-questions. So the question here is, how much do moms and dads talk to their sons and daughters? So we have about 635 kids there, it looks like, and split roughly evenly between boys and girls. And they all have a mom and they all have a dad. I know not all children do. These particular ones did. Um, and we put recorders on them and we measure them. And uh, on the y-axis is an estimate for utterances per day. So we can look at that, and the green bars show that moms talked more than dads, and that's obviously a highly significant result. And so moms are uttering something like 11,000 utterances per day. These are roughly syllables, so about 11,000 syllables, 11,000 words, 11,000 utterances in a day. And dads are more like 5,000 on average. And I'm a dad, and so I'm interested in what dads do. And many years ago, when I was first sort of thinking about these things, I was sitting in my lab with a couple of my graduate students, and I said something about motherese, and the students didn't know what motherese was. And one of them sort of snarkily said, "Oh, that's very sexist of you, Dr. Van Dam, to think that it's only the mothers that talk to their children." I said, "Oh, no, 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 it's a word that, is used in the literature and so on." And I said, "Well, what about fatherese?" So we sat down at the computer and started to examine the scientific literature and look, well, what about fatherese? Turns out no one really has looked at dads. No one has cared so much about dads and their assumptions built into a lot of the literature. So since I'm a dad, I started thinking, well, let's examine how dads might be different from moms and how much they talk. And maybe dads are different. They interact differently with their girls than they do with their boys. And it turns out that's exactly what we found. So dads having significantly more utterances directed to their boys than directed to their girls. And moms seem to be equal opportunity conversationalists. So moms have no difference between their boys and girls, although you can see a slight advantage of the moms to the girls versus moms to the boys. So this is kind of an interesting result. And we can jump off from this into lots and lots of different questions. I'd also like to point out that I have this, I'm quite interested in trying to apply this to real problems in the world. And I'm not a clinician myself. I'm in a speech and hearing science department. We train SLPs by the dozens, and they go to the clinic by and large, and they become clinicians. Results like this could absolutely be incorporated into clinical practice in meaningful ways. I don't know exactly what that is because I'm not a clinician. But if you know that moms talk far more often than dads, that could help understand how different families interact and maybe influence how we think about education, how we think about intervention, how we think about a number of different ways that this could actually get to helping real people or be incorporated into clinical practice, educational practice, those kind of things. Have you ever wondered how much language exposure a toddler gets? Elika Bergelson and her team have made some estimates of this. About 200 utterances per hour, about 10 and a half hours a day. A 3-year-old is awake. There are the standard number of days in the year. And if you carry out that arithmetic, by the time a kid is 3 years old on their first birthday, they have been exposed to about 2.3 million utterances. So this is a sort of Steven Pinker type calculation. And of course, there's lots of variability and lots of variation in these things. So people are certainly looking at these things and trying to understand how the relationship to exposure might help us explain things about speech and language development. This also has a very interesting implication for Chomsky's famous poverty of the stimulus. And I will leave it to the listener to try to think about whether the stimulus is actually impoverished or not. That black and white figure on the upper right was a study we did that will, I imagine, surprise no one. And on the x-axis shows the amount of electronic media, TV and radio, in the environment of the kid wearing an all-day recorder. And on the y-axis is the number of conversational turns that the kid engages in that day. It's a normalized number. Kids engage in far more than 70 conversations in a day. This is a by hour rating. So as you can see, that negative slope of that line shows that if the TV's on a bunch more, then you engage in fewer conversations. And of course, conversations facilitate language learning. A lot more TV does not facilitate language learning. So we have empirical evidence here with the suggestion to turn the TV off if you want to engage in more conversations with kids. Here's a picture of my daughter. She's a little older. She's about 2 in that picture, I think. And we had another project we worked on in which little Alice there wore a recorder starting at 8 days old and wore it most of the time, more than half of the days, until she was 500 days old. So for her first 16 months of life, we collected almost 300 day-long recordings for her. That results in just under 4,000 hours of audio for this one kid in my family and in my house. Just for a little context there are 12,000 hours in 501 days of life. And we estimate she sleeps about 7,000 of those hours and is awake about 5,000 of those hours. So we have about 4/5 of her total waking hours recorded from her perspective. And we can then, and we have done a bunch of analysis of her speech and language development. When she was 8 days old, she had 0 language, of course. I mean, nothing. And by the time she's a typically developing kid, by the time she hits 16 months old, she is a very experienced language user, and you can very well have conversations with her. I mean, she's not a whole lot past the 3 and 4 word stage, but she's a postlingual person. So we can look at all sorts of details of this, and in particular phonetic production of those things. And there are some examples of those, some of the analyses that we did there on the left-hand side, looking at the longitudinal development from I call it a super longitudinal micro analysis of this, to look at how her speech develops over the course of her first 1.5 years of life. I can tell you too, this particular project makes me a little nervous because I haven't shared this particular piece of data because it's recording in my house, in my family. And that makes me feel a little funny. The recording is of conversations that were had in our house. And there are privacy issues, and there are issues of, well, what kinds of conversations we're having and that sort of thing. So that's another issue that we have to deal with these day-long recordings that are taken, au naturel, that we have to manage and think about some of those things. Let's talk about some kids with hearing loss and how these kids pattern. So here we looked at number of utterances per day again, and we find that how often the mother talks, the father talks, and the child talks. And we find some repeated results where moms talk a lot more than dads, and dads talk a lot more than children. These are about 2-year-olds in this particular study. And then the red bars represent the hard of hearing kids. These are mild and moderate, well-intervened English-speaking kids. And the hard of hearing kids in the red bars, and the typically developing normal hearing kids in the blue bars. And we find a wonderful non-result here. And the non-result is that hearing loss doesn't seem to matter. That is, the moms, the dads, and the kids aren't particularly sensitive to the fact that the kid has hearing loss. And that's very good. Mothers talk to them about the same, fathers talk to them about the same, and the kids produce about the same. And the differences aren't statistically significant. Some more empirical work, some of this with kids with hearing loss, some without. In the upper left there, we find that we have only children compared to kids in families with more children than the target kid wearing the recorder. And we measure mean length of utterance. Mean length of utterance is estimating about how many syllables the kid talks in an utterance or in a breath group. And the longer that mean length of utterance, the assumption is that the more complex the language is. So we take these recordings, we use automatic procedures to estimate how long those utterances are, and we find that only children have longer MLUs than kids who have siblings. Maybe they're not getting the airtime, maybe they're competing. In our case, those siblings are typically older because we record quite young children. So there are a number of factors that might explain some of this. In the lower left, kids with hearing loss, in the red, and kids who are typically developing in the blue there. And we estimate type frequencies per hour. And type frequencies and token frequencies are also measures of language complexity. So a type frequency is how many different types of words these kids were exposed to. In this case, we use the automated methods in conjunction with real live people who did transcriptions. So we take the day-long recordings, we run it through the software, we get those labels, and then an army of master's students and undergraduates in my lab do manual transcriptions of these and calculate things like type frequency, token frequency, mean length of utterance in some cases. And in the lower right there, girls have a higher type frequency than boys for young children, 2-3-year-old kids. And in the upper right there, the pink ones are the girls and the blue ones are the boys. And on the x-axis is the kid wearing the recorder. And on the y-axis is the sibling of the kid wearing the recorder, also collected by the recorder. So we had a hypothesis. If the kid wearing the recorder is highly voluble, does that mean that the siblings have either a positive or negative relationship with volubility? So would a talkative kid predict that the sibling is also talkative, or is the talkative kid taking the airtime and not letting his brother or sister talk? Or the third possibility is there is no relationship. And that regression line through the middle has pretty clearly a flat regression line and shows no effect of volubility of the target child on the siblings, which is another kind of interesting result. Another recent paper looks at who initiates conversations. And we put many thousands of days of recordings at this problem and run it through the automatic analysis. And we look at all of those cases in which there is a parent and a child in an interaction with a temporal relationship to one another. So we don't measure when other kids are talking. We only look at when the target kid is talking, and then whether those target kids initiate a conversation or whether they're the recipient of that. And we look at potential differences between boys and girls, boys on the left, girls on the right. And we look at whether mom initiates or dad initiates in the different colors, and whether there's interactions between typically developing kids and hard of hearing kids. And we find that in this case, moms initiate far more conversations than moms initiate far more conversations than dads. And that, again, another happy non-result is that the kids with hearing loss don't appear to pattern differently than the typically developing peers. And we find that boys and girls don't tend to pattern differently either. So the smear of four distributions on the left patterns similarly as the smear of distributions on the right. And conversation initiation is important because if you are the one who initiates, you get to pick the conversation, you get to pick the timing of it, you get to pick the topic. So there are certain advantages to language learning and development if you pick where conversations start. We did another project that was technically very simple and very straightforward, but we wanted to know what it was like auditorily, not so much from a language perspective, although there are certainly language and development implications. We wanted to know from an auditory perspective, what's it like for a hearing impaired kid versus a typically developing kid? And if you've ever been in a deaf community, like a deaf classroom or a residential deaf environment, I remember the first time I went into one of those, I thought, oh, this is going to be auditorily boring. It's going to be quiet. And I walked into it as actually a residential school in Council Bluffs, Iowa, where we went to the school and heard the kids, and it was loud. Kids were making all sorts of noise, and that surprised me a little bit. So we put a bunch of kids. Each one of these dots is a day-long recording from a kid, and then we plotted boys versus girls, and we plotted typically developing versus hard of hearing kids. So the Christmas colors, the red and green there, are the hard of hearing kids, and the blue and black are the typically developing kids. And we plotted the daily gross mean amplitude of the whole day for the kid. So the kid wearing the device, how loud is it on average in dB based on the kid's age and the day-long recording? And we found a really surprising effect. And this is a classic interaction effect here. The first thing to notice is that there's no difference between boys and girls. They pattern the same. Those Christmas colors and the blue and black are more or less overlapping. But one of them has a positive slope and one of them has a negative slope. So that means that for the typically developing children, they get louder as they go from birth to about 60 months, so about 5 years old. The hard of hearing kids get quieter over that same time span. And then there's a crossover point. That crossover point is at about 40 months. And we speculate or hypothesize that something happens at about 40 months called theory of mind. And that's when young kids start to realize that other people have different thoughts, feelings, and emotions than they have in their own social and linguistic worlds. So at about that time, kids start to realize that they are independent actors and the people around them are independent actors. And maybe they start to get a little quieter at that time. Another study we did, actually a whole family of studies we did, looked at infant-directed speech or child-directed speech, CDS, versus adult-directed speech. And this is, so when we talk to little kids, we sometimes change certain features of our speech production. We say, aren't you so cute? And we raise our pitch and we talk a little faster. Maybe we talk a little louder. Maybe we talk a little slower. We were interested in pitch in this case, so we measured fundamental frequency. And we were interested in hearing impaired, the distinction between hearing impaired kids and typically developing kids, and between moms and dads. And these two figures here, the figures in the middle there, the moms are on the left and the dads are on the right in the blue. And on one axis is child adjacent speech, and on the other axis is parent adjacent speech. So if the markers in the figures fall on the bisector line, like the dads do, then their fundamental frequency is about the same in the adult directed as it is in the child directed. The mothers, on the other hand, all fall to the southwest of the line. So the mothers raise their pitch when they talk to their children, but the fathers don't. So mothers are doing something very different than the fathers are doing. And the open figures are fathers and mothers of typically developing kids, and the filled figures are the hard of hearing kids, and we find another happy non-effect where we find no statistical difference between those. So the parents don't seem to care if they have hearing loss or not. I think I'm going to leave this one for the reader. We looked at this one. Again, this was about 30,000 hours of audio, 273 kids, almost 2,000 days of recordings. And here we compared speech development, vocal development in 4 groups: typically developing, hard of hearing, language delay, and ASD children. And we found some differences in the way that those children pattern over a longitudinal analysis of those kids. And then I will leave you with just a reminder of these big picture things that we're interested in. So all these empirical studies that we do and all of this methodology that we're interested in applying to those are still about cognitive development and how kids develop speech production and speech perception capacities, and then specifically how hearing loss impacts those and the cognitive and linguistic consequences of hearing loss. So now I'm happy to take questions from you, excuse me.